In this video, I will show you how to graph this data set by hand, as well as calculate the slope and to derive the math model. So this data set is for a baby. We have age in months and then weight in pounds. Our age will be our independent variable, our purposeful change. We're deciding to collect data at these ages, and then the dependent variable, our response to change, is the weight, which is measured in pounds, or our response to the change. Okay, so we're going to first draw the axes. So I'm going to draw my vertical axes, and we want to make these rather large. And then this is my horizontal. Once we have our horizontal axes, we're going to label our axes. So on the independent variable typically will be on the x-axis. So I'm going to write age here in months. And we do include the units here in months. And then on the y-axis is going to be weight in pounds. Okay. Then the next step is to title the graph. And typically it's just going to be whatever's on the y-axis versus whatever's on the x-axis. So this will be weight versus age. Okay. And then the next step will be to scale. And the way I like to scale is to take the largest number. So let's put this right here. So we're going to take the largest number on the axis divided by the number of boxes. So this is just one method. You don't have to do it this way, but this is one way to figure out how to scale the boxes. And so the largest number on the y-axis, weight, is 16.7. And then I'm going to count the boxes, and the number of boxes from here going up is about 24. And if I take 16.7 divided by 24, I get 0.7. Now to go by multiples of 0.7 is not super easy, 0.7, 1.4, but it gets a little bit tough as you go higher and higher. So we're going to round it to an easier number. So we'll typically try to round to a 1, 2, or a 5. Okay, so I'm going to take this 0.7 and round it to a 1. Okay, so that means I'm going to make every box worth 1. So 1, 2, 3, but I'm not going to write a number for every box because it's going to get too crowded. So let's go ahead and do it for every 2 boxes. So then we're going to get 2, 4, 6, 8, 10, 12, 14, 16, and 18. Okay, so I'm going to do the same thing for the x-axis. I'm going to take the largest number on the x-axis, which is 8. I'm going to take 8 divided by the number of boxes. And there's about 36 boxes there, so I'm going to write 36. So 8 divided by 36 is 0.22. And once again, I'm going to round this up. Okay, I'm going to round this up to one of these numbers to make it easier to work with. So I'm going to round it up to 0.5. So each of these boxes is going to be worth 0.5. That which means 2 boxes will be worth 1. Now I don't want to go by 0.5s down here because if I write every single number, it's going to get real crowded. So instead, I'm going to do every 2 boxes is going to be 1, or 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so now that I've scaled the axes, the next step will be to plot the data. Okay, so I'm going to bring my data back here. And the first one I'm looking at is 1 and 7. So 1 and 7, 2 and 9.4, 2 and 9.4, so just a little bit under 9.5, 3 and 10.5. So between 10 and 11. Okay, 4 is 12. That's easy. That's right there. 5 is going to be 13, between 12 and 14. 6 is 14.3. So 15, 14.5, 0.3 will be right here. 7 is 15.2, so just a little bit above 15. And 8 is 16.7. So 16.17, 16.5, 0.7 will be right there. Okay, so now that I've plotted my data, the next step is to draw the best fit line, and I'm going to use a straight edge to do this. So a best fit line is not connected dots. It is a straight line. It's as close to as many of the dots as possible. So I'm just going to try to get it as close to as many dots as possible, and then I'm going to draw this straight line. And once again, it doesn't have to touch every. It does not have to touch every dot. Okay. So I'm going to next calculate the slope of this line, and to do that, I'm going to need to pick 2 points. I'm going to pick this point, okay, and then I will also pick this point. So I'm going to pick these 2 points. Okay, here are the coordinates: 1.5 and 8, and this one is 4.5 and 12. 4.5 and 12. Okay. And then the next step will be to calculate the slope. And I'm going to use, slope is rise over run, but I'm going to use this equation here. Slope is equal to y2 minus y1 divided by x2 minus x1. Okay, so now I'm going to do the substitution. So this is y2 and y1, so it's going to be 12 minus 8, okay? And then x2 minus x1 is 4.5 minus 1.5, so 4.5 minus 1.5. Okay, so we got 4 on the top. 12 minus 8 is 4. 4.5 minus 1.5 is 3. So we end up with 1.33. 1.33. So our slope, and the symbol for slope, we're going to use m here, is 1.33. And the units are pounds over months, because slope is rise over run, so it's pounds over months. So the unit on the y-axis divided by the unit on the x-axis. So it's going to be pounds per month. Okay, so the thing to first think about here is, what does that represent? What is that telling us? And in physics, our numbers have meaning. So this is telling us that for every month, the baby is increasing its weight by 1.33 pounds. Okay. The next thing we're going to look at is the y-intercept. I'm going to use a symbol B for that. If you look over here, you'll see that that's at 6. Okay, so 6 pounds. So 6 pounds. And once again, I want to ask the question: what does the y-intercept represent? What is the 6 pounds telling us about the baby? And so this is occurring when the baby is at age 0, which means that this is the birth weight. Okay. Now let's take a look at the graph and think about what kind of graph this is. We have different kinds of graphs, and this one is called, notice it's a line. It's pretty linear. So we say that this is a linear graph. Okay, and in a linear graph, we can come up with a math model using this template: y equals mx plus b. Okay, the y is whatever is on the y-axis. In this case, it is the weight of the baby. The m is the slope, which is 1.33 pounds. We're going to put the slope right here: 1.33 pounds per month. And the x is what's on the x-axis, which is going to be age, plus the y-intercept, which is 6 pounds. So this math model is really helpful and powerful, because if you know the age of the baby in months, you plug it in here, and then it will tell you the weight of the baby at that age. Right? So this is what we call the math model. It basically is just a math equation that allows us to be able to extrapolate what the data that we got. So we could plug in other ages and then find out what that weight of the baby is at other ages. Now we can also write a written description of this relationship. Since this is a linear relationship, we can say this: as age increases, weight increases proportionally. So in this video, we drew the axes, labeled the axes, we titled the graph, we scaled the axes, we plotted the data, we drew the best fit line, We picked 2 points and calculated the slope. We asked the question, what does the slope represent? We recorded the y-intercept. We asked the question, what does the y-intercept represent? We derived the math model and wrote down the written relationship.